How can we use this to try and help graph something? Well, let's take a look real quick here. Let me find my graph paper. And let's go with this equation. They want us to sketch x minus y squared equals 1. Okay. Now, I can do an XY table, plot a whole bunch of points, hope I get it done right. But let's do this. Let's do a couple of those checks that we just talked about. So let's check first and see x-axis, if there's symmetry. We said we'd change y to the opposite. So we would do x minus negative y squared equals 1. Now notice again, I changed where the y was to negative y. I didn't let the original subtraction become my negative. So this one, negative y times itself, just becomes y squared. And yep, we're right back to where we started. So there is going to be symmetry with the x-axis, which means anything above the x-axis will be mirrored below the x-axis. All right, let's take a look at y. Our y-axis says change all the x's to negative x. Now, all I can really do with this one to simplify back to a positive x would be multiply by negative 1. I would have to do that for all of them. So really, this would be all I could simplify, which doesn't get me back to where I started. So no, I don't have symmetry with the y-axis. And let's take a look at origin. So symmetry with the origin says we change both. So x becomes negative x, y becomes negative y, and we simplify. So I get negative x, again, negative y times negative y is positive y squared, and it's subtracted. So I get that. Now again, if I want to get this x back to a positive like the original, I can multiply every term by negative 1, which gets me this, which again is not what I had up here, so that's a no. Now again, our goal is to use this symmetry. The only one that worked was our x-axis symmetry. So now let's see, how does this really shorten things up for us here? Well, let's set out our axis here so we can graph this. So here's our axes, x and y axes. So let's simplify this a little bit. Now x-axis is going to be where we set this up. Now let's go through our steps that we just did a little earlier, where we said try and isolate one of the variables. So let's try and get x by itself just to make it easier. So I can add y squared to both sides, and I'm going to get x equals y squared plus 1. Why do I want to do that? Because now when I do my xy table, I can plug a few things in for y, find x. The order doesn't really matter. So let's say we're going to put 0 in for y. 0 squared is 0, 0 plus 1 is 1. So there's one of my ordered pairs, 1, 0. So we go 1 to the right, nowhere up or down. Now again, remember, our x-axis is our mirror. Well, if I'm on the x-axis, I can't do a mirror yet. Well, let's let y be 1. So if I plug 1 in here, 1 squared is 1, plus 1 is 2. So now I've got an ordered pair of 2, 1. So I would go 2 to the right and 1 up. Now instead of finding another point right away, because the x-axis we did have symmetry, I can drop down and do my mirror image. If y is 2, 2 squared is 4, 4 plus 1 is 5. So I'm at 5, 2. So 1, 2, 3, 4, 5, 1, 2. And again, we save time by knowing that the x-axis is where our symmetry falls. So I'm 2 above, I can go 2 below, and now I've got a pretty good idea of my shape. So now I can just draw my smooth curve, connect my points, and we've got our graph. So the symmetries really shorten things up for us quite a bit. Alright, we can use a little of this for the last part of section 1-2, which is dealing with circles. So, first of all, let's go back and we'll take a look at a standard form for a circle. Oops, let's get the change over here. So our standard form of a circle is going to be this. Our standard form for the equation of a circle is going to look something like this. X minus h all squared, y minus k all squared equals r squared. So that's standard form for the equation of a circle. Now, what do all those pieces mean? Well, as an ordered pair, h and k is the center of our circle, and r, not r squared, but r, is the length of the radius of our circle. Now, one of the special cases would be this. You could get x squared plus y squared equals r squared. All this means is the h and k are 0, so this would mean a special type where the center's at 0, 0, and r is still going to be the distance of your radius. Alright, so let's do this and find an equation that we can work with. So we'll switch pages here again. And on this one, they're only going to give us a couple bits of information. They're going to tell us this. We have a point at 3, 4 that lies on a circle, and that circle's center is at -1, 2. Alright, so when we look at this, we've got h, we've got k. We've got a generic point here, which is basically giving us an x and a y. So let's set up our equation for our circle. So we're going to do x minus h all squared plus y minus k all squared equals r squared. So let's substitute in what we know. So in this case, our x is 3, our y is 4, h is -1, and since we're doing minus that, it becomes +1, so we're adding the opposite. And then the k was 2, so we go -2. So basically we filled everything in except r. So we're going to find our radius. So when we simplify this one, 3 plus 1 is 4, so we get 4 squared. 4 minus 2 is 2, 2 squared, and then finish it out. So 4 squared is 16, 2 squared is 4, so we get r squared equals 20. Now I really don't need to know what r is itself, our radius. If I needed to, I could find square root of 20 and simplify that. But because all they want is the formula or our equation, we're going to take this and we're just going to fill in h, k, and r. So our standard form for this particular set would be x plus 1, because it's minus a minus, that's squared, plus y minus 2, that's our k value, that squared equals r squared, which is 20. And there's our equation for the circle that has a center at -1, 2 and goes through the point 3, 4. So a lot of plug and solve, and away you go. So use this in some of your application problems in 1, 2, and that should take you through that section. So good luck with that.